My name is Bart Brecka. I work at Design Engine, where Design Engine is a product development company. We do a wide variety of projects. We also maintain a school where we teach our customers what we did on the project. Usually the classes are with respect to Creo or SolidWorks. In this video, I'm going to create a part that from various hats. We're going to build it like R&D. We don't care how it's manufactured. It's 3D printed, and we're going to build it. Then we're going to change that into a manufacturable part. And I'm going to do it a couple different ways. This will be a handful of videos, maybe 4. So the SolidWorks Learn to Design course, basically this is a week-long course. Each day is broken up. This exercise I'm getting ready to present is in the second day. This shape can be built several different ways. You could sketch the Y shape, or you could sketch the oval shape. In a different example, I'll sketch the Y shape, and in this case I'm going to sketch the oval, and then I'm going to cut out the geometry and build an assembly. Let's start. So I've already started a part. I didn't save it. Typically SolidWorks users will leave the data planes off. I like to choose the right plane because that's maybe the plane that I expect to establish in my detail drawing. I also, when I build a geometry, I try to make it so it's clearly not symmetrical. So when I do force symmetry, I can see the symmetry occur. Also, when I build a center line, I tend to put it just a little bit off to the side so that when I force symmetry, it's a little easier for me to fetch that center line, right? And there. So you saw me move my mouse all the way around to the other side. Usually when I'm teaching a class, I focus heavily on the speed and effectiveness of the software. Look, I've got this symmetric tool and a pop-up window, which makes me a lot more efficient. If I hold down and fully define the sketch, it doesn't often dimension it the way I like it to. Also, I want to delete these edges and establish an arc at the end. All right, so notice how I've got tangencies on each one of those. Sometimes sometimes you don't get the tangencies. In this case, I'm going to delete the tangencies and kind of put them in again. So the typical SolidWorks user will click one on the other and then fetch tangency. A lot of people don't know it, but you can just click the dot and force tangency in that way. If you leave one off, your part, when you modify it, it can affect how it updates. So in that case, we tend to encourage young people to fully make the sketches black. In this case, I feel like something's off because I've got tangency everywhere, and my sketch isn't black. So I've got to kind of figure out what the problem is, and typically I just modify it to see how it's going to behave. Oh, maybe I don't have symmetry going in one direction. Yeah. So in this case, I lost my symmetry going in this way. Great. So I'm not going to worry about the size too much, but we are going to make this in a separate video manufacturable. Now you saw me check out of the sketch. That's by habit. SolidWorks, you don't have to check out of the sketch. You can just fetch extrude over here and extrude the geometry. I happen to had picked midplane earlier, but if you don't have midplane picked, you can hold down anywhere and fetch midplane out of this pop-up window. Pretty handy. Right, now I'm going to build, I might want to take a look at my sketch to kind of get my bearings. I'm going to cut this section out of the middle. So let's establish that sketch pretty quick. I don't always feel compelled to look straight down upon something, but that can be kind of helpful. Also, I think it's helpful. I want this to be symmetric, but I dimension it so it's not symmetric, so that when I get symmetry to occur, I see it pop. I think that's super helpful. So pre-select the selections and wait to look for my symmetry function. I know that SolidWorks had, and their competitors don't let me use any sort of AI to define how I want to sketch, these sketches to be established. I think that would be super helpful. I'm not involved in the development of SolidWorks or NX, but I've been pushing people to do that for well over 20 years. So instead of hitting the checkbox, I'm going to right hold down and fetch extrude. So if I make a mistake and extrude a solid where I mean it to be a cut, you can just double click on the thing and drag it in the other direction and it converts it to a cut. I've never seen a SolidWorks user know that one. There's a lot of cool little tricks in here that can be had if you were to take a SolidWorks update training. The software has changed quite a bit in 20 years, and people tend to think they know everything about the tool. Now, I'm getting ready to create another sketch that makes sense to me, but most users, what they do is they make the sketch that's already there significantly more complicated. I tend to establish new sketches. I think that's helpful. And if you're mindful, look how that sketch can pop to the other side. That's really helpful. I didn't do that on purpose because I want to show you can get the same thing by using this collinear tool. I think it would be helpful to fetch collinear through the assumptions. All right, so I have the center line here still. Let's dimension one side to the other. I think that's pretty helpful. Notice the other side didn't turn black. So in SolidWorks, you can pick the vertice and the center line and get symmetry. You can also pick the straight line, and it doesn't really matter what order you pick them in. All right, and how do you want to control this one? I can dimension it to the center. So after dimensioning it, what seems to be appropriate, we can come back and change our mind if we like. What I want to point out is this edge, when I turn this cylindrical face to an eyelet where it's got draft on it, this collinear reference or this coincident constraint is going to fail. And I think it's helpful to anticipate these failures. You're just smarter if you can handle fail mode a lot more efficiently, more effective. And I want to be mindful of what problems the manufacturing engineer is going to have, because maybe I can help them or build it a different way so there's no problem. Let's go ahead and build an assembly now. So I've got to save this part. I'll call it block 16. It was, I'll name the assembly exactly the same thing. The file extensions are different, so it's okay. I'll just double click on block 16 and hit the check box. Notice the F in front. Now, I speak English as a first language, but somebody who speaks English as a second language is definitely going to get mixed up. Does F stand for fix or float? So if I right hold down on this thing and float it, now the minus sign means float. The F meant fixed. So it can be a little confusing for people that speak a second language. I'm just going to move it off to the side for a second. Now, I want that thing completely fixed to the coordinate system. So I'm going to turn on my coordinate systems. A lot of SolidWorks users tend not to care about this sort of detail, and I'm maybe too picky, I don't know. But now I've used the make constraint and actually got rid of the F and the minus sign. I'm completely constrained to that coordinate system. I think that's extremely helpful. Now I'm going to grab this part here and hold my control key to establish a second reference. And then I'm going to make look, I've got the minus sign. I'm going to make a reference to this cylindrical face. I think this is a bit of a mistake, but I'm going to fix it later and talk about why one might want to use a different reference. Let's now turn on my datum planes, and let's make one reference to the other reference. Cool. Right click to establish that reference, and then I still have the minus sign because I didn't give it a third constraint. if I gave it a third constraint, I wouldn't be able to move the geometry. So in other packages, there's a reference inside of here that says, ignore the fact that I need a third constraint, so I'd like to make that go away. I don't believe SolidWorks has that functionality. And if it does, somebody can correct me in the notes, comments. All right, so let's do that again. I'll hold the control key down, create another one. I'm going to leave this one kind of floating. Now, if I come over to my part itself and had a little smarter way to build this, I wouldn't have an axis down the middle here, or a cylindrical face. I'd want to have an axis down the middle, and you know, maybe build everything with holes, or there's another way to build this thing. Definitely would like to have an axis down the center. So in some CAD packages, this point will mature to an axis. I don't believe we have something like that in SolidWorks or NX, so I'm going to go ahead and try to think of another way to do it. Now, this seems like a little bit of work, but it's pretty handy. I'm going to build a circle where I expect this to occur, the center. Okay, and maybe this needs to be coincident, like we do. And in a separate video, I'm going to explain how this is helpful. I'm going to go ahead and extrude it as a surface. Now that I've extruded it as a surface, what happens here is it automatically creates an axis down the center. See those axes? That's what I want to organize myself to. A lot more effective. We'll come back and do that in a separate video. So let's save this assembly. I'll call it also block 16 because it's the block 16 assembly. And on this one, I'm going to create the reference to the axes, a more teamed approach to establishing references, because if something fails, I'm apt to be able to fix it. Okay, and I'm checking out of here. This third check means I don't care about the third constraint, so I'm just going to hit the check box, and I still have the minus sign, and let's test it to see if we can kind of wiggle it like a 3D printer chain that it is. All right, so in the next video, I'll create everything to be manufacturable, and I'm going to have to deal with some failures. And I just want to point out that to be considered an expert, you manage failures without complaint. Consider taking a class at Design Engine, and if you're interested in a capabilities overview by